Pack them in. It's a big, how many of you guys, there's like 50 of you guys here today. I want to see a lot of Facebook posts. Kid got to go tag Manley Labs. Cool, come on in, don't be shy, come. Pack them in.
This is not for the claustrophobics of you.
Come on in, everybody. They're from Art Institute out in San Bernardino. It's not far away.
San Bernardino.
Is everyone in? All right. Is that insulting to say so?
No. That's only if you said Rialto.
Well, like I mentioned, we started building George's Fun GML products in 2001. 2001. GML had a factory in Van Nuys, and Manny started working for George in 1988. And Manny's problem is he lives out like near Hemet, and he used to have to drive 2 hours to work to get to work, and 2 hours to get home. That's almost more time than you actually work. Yeah.
You're right.
So Manny, for one, was very happy to get his commute cut in half. So we brought Manny over here and all the parts and set up manufacturing here at Manley Labs for GML, and that line we'll walk through next. Here is where, after it's built, it all gets checked out. So you can see Manny's got some audio precision set up here, and he's going through a set of tests to calibrate this mastering, what's this thing called, 2032? Mastering 2030, sorry, 2030. And that's the mastering version of the 8900, which is George's famous limiter compressor thing. It's called a dynamic range controller in George's world. So Manny's going to measure a whole bunch of stuff. He aligns all the trim pots that need alignment. He's going to listen to it. He's going to measure voltages and do all that stuff to make sure that this thing's working exactly like it's supposed to work.
Cool.
And to get to that point, you have to build it first. We'll get there next. Have you guys worked with audio precisions before, like measuring, or worked on a test bench before?
No, that's not, no.
Y'all are building stuff. Is that right?
Yeah.
You guys are, how do you test it? If it's working?
Plug it in.
Fire? No fire. Okay. Cool. So, no smoke, it works. Do you guys measure voltages and stuff with meters and things like that? What other things do you measure?
Resistances, like go through the ohms laws and stuff like that.
We just did the
Kirchhoff.
Yeah. Good. Yeah, well, yeah, that's it's important to, when you're building something, to diligently go through and measure all the voltages on all your capacitors and make sure you didn't forget and put a 10-volt cap where you really need a 25-volt cap or something like that. And also, we've been guilty of this a million times too. It's like, oh, that's a 1/4-watt resistor. It should have been a 1-watt resistor. And you measure your voltage drop across the resistor, and you square up the voltage and divide, what is it, V squared over R, yeah. Square up the voltage, divide by the resistance, and then you got some watts, and if it's more watts than the resistor says he is, you got a problem. So, yeah, always check your capacitor voltages and your resistor dissipations and make sure that thing's going to keep working. You can do that with a calculator and a flute. Definitely, you don't need all this fancy stuff. So, but one day, if you're really interested in electronics, you would set up your own test bench at home to be able to play with this stuff. And you would have an oscilloscope so you can see a graphical display of your waveform. You probably wouldn't have an audio precision. Those cost thousands and thousands of dollars. You would have some kind of signal generator that's puking out some sine waves for you at different frequencies, so you can look at a 1 kilohertz sine wave or a 10 kilohertz sine wave, and so on. Sometimes you'd have something like a distortion analyzer, so you could see like how that thing's performing, what kind of distortion products it's putting out. You would have some speakers and some fine amplifiers so you can listen to your design. And also listen to noise, that's a real important thing that we fight here, you know, buzz and hum. And they're always caused, I mean, they can be caused by different problems, you know, buzzing versus humming can be different things. So you set up a bench at home to be able to play with electronics. Have a good soldering iron, there's one right there, some hand tools, trusty flute meter, stuff like that. It's fun. Electronics is fun. We love it. If y'all have any questions anytime in the tour, you gotta speak up.
I have a question.
Yes.
All right, so last night we were running drums and bass through the what, guys? The Varimu.
Yeah.
Okay, and it definitely takes the sound and makes it more three-dimensional and bigger.
Yep.
How do you judge when you're building it when it's the way you want it to be? Is
Well,
it a
That's a great
mathematical
question.
choice or is it an aesthetic ear
It's a
type
lot
thing?
of everything.
Okay.
A lot of experience in the real art in what, that's a great question. The real art, I guess, in what we do when we're developing stuff is to know what sound we're looking for, what actually would cause that, and what we can change in the design to make that happen. So, like distortion, like maybe you know, knowing what odd harmonic distortion sounds like versus even harmonic distortion. Knowing what distortion in the bass sounds like and how that might make something sound thicker. So if you say, okay, I want it to sound big and fat in the bottom, then you say, well, maybe I want to introduce a little, you know, purposeful distortion in the bottom to make it sound like it's big and fat, okay? And then, so how am I going to do that? Well, maybe I'm going to change the whole circuit topology. Maybe I'm going to purposely lower a voltage to make something distort earlier. Maybe I'm going to redesign my power transformer to make it fall into distortion earlier. So the art of what we do is complicated, and we learn it all just from experience. You know, like one day something was screwed up and I figured out, oh, well, that's why that did that. It's because that was broken. And then you put that on your list of things I know about, right?
Yep. Cool.
And it's just like having a lot of tools in your garage to monkey around with. So yeah, it's like, okay, if I want big fat distortion in that power amplifier, and this is a true story with that transformer. Well, I'm going to redesign that transformer so it has less inductance and will saturate earlier in the bass.
Perfect.
Like that. And to do that, we have a transformer one department upstairs so we can monkey around with that stuff.
Great.
But that is the kind of art of what we do here, and just you have to just keep observing things as you play with electronics and remember these cause and result.
Keep good notes.
Keep some notes, yeah. Yeah, I know a lot of my buddies keep a lot of design reference notes and things like
There's
that.
so much stuff that you go through, it's so hard to remember all of it.
Yeah.
Question for all of us right there.
What's that?
Yeah.
Question.
That's also
yeah.
art in itself. I mean, well, definitely, like making the sounds, or making these instruments make the sounds like that.
Oh, yeah.
That's an art in itself right there.
Well, I'll show you guys in the tour. I'll pick up on, I know a couple examples. I can show you examples of exactly what you're talking about there, like what a wire choice did.
Yeah.
What?
Just for a minute.
What's that mean?
Romeo's Crew?